Okay, so let's look at synthetic substitution. Okay, so look at the polynomial function that we have here. We have a degree 4 with a leading coefficient of 2 and 1, 2, 3, 4 terms. So if we wanted to substitute in and find f of negative 3, I know that I would go through this polynomial function, and every time I see an x, I would replace it with negative 3. Okay, and then of course I'd use order of operations. I'd have to do my 3 exponents first. Negative 3 to the 4th power is going to be positive 81 because 4 negatives make a positive. Negative 3 to the 1st will be negative 27 because 3 negatives make a negative. And negative 3 squared is positive 9 because 2 negatives make a positive. After my exponents, I need to multiply through. 2 times 81. 5 times negative 27 is negative 135. 9 times 2 gives me negative 18 minus 8. That's going to leave me with addition and subtraction. So left to right, 162 minus 135 is 27. Then 27 minus 18 is 9. And finally, 9 minus 8 is 1. So that tells me f of negative 3 is equal to 1. So I know x is negative 3 and y is 1. Now, synthetic substitution is another way to do exactly what we did here. So with synthetic substitution, what you'll do is you'll take what you're substituting for x and you'll put it on the outside of your synthetic substitution bar. The synthetic substitution bar is your division bar flipped upside down. It looks like an L. So we're going to take each coefficient for every variable from x to the 4th down to the constant term, and we're going to put it from left to right inside my L. So this being a degree 4, I'll take its coefficient of 2. Then I'll go to my 3rd power, which is a positive 5. Then I'll go to my 2nd power, which is a negative 2. Then I'll go to my 1st power. Well, I don't have a 1st power, but it has to be accounted for, so I'll put a 0 there as a placeholder. And then finally, my constant term is negative 8. To complete synthetic substitution, what you'll do is you'll take that first number, which is a 2, and bring it down. And then from there, we'll multiply and add. So negative 3 times 2 is negative 6. Put it in the next column and add the next column. 5 plus negative 6 is negative 1. Then multiply again. Negative 3 times negative 1 is positive 3. Put that in the next column and then add that column. Negative 2 plus 3 is 1. Multiply again. Negative 3 times 1 is negative 3 and put that in the 4th column. 0 plus negative 3 is negative 3. And then multiply again. Negative 3 times negative 3 is a positive 9. And add that last column to get positive 1. The number that you get here on the very last column should be the solution for when you evaluate your polynomial when x is negative 3. And you see when I plugged in negative 3 and worked it out, I got 1. When I used synthetic substitution, what did I get as well? 1. So this also tells me that f of negative 3 is equal to 1. And that's what synthetic substitution helps you with. It's a sometimes quicker way to do your substitution. Okay, so the next thing I want us to talk about is synthetic or long division. We'll do synthetic division in a little while. So let's think about what division is, okay? So if you have 225 over 14, that's the same thing as 225 divided by 14, right? So I know that the 225 is what we call my dividend. The 14 is my divisor because that's what I divide by. You divide bottom into top or right into left. Okay, so when I divide and I set up my division problem, the divisor goes outside, the dividend goes inside. So let's divide and see what happens here. 14 will not go into 2, but 14 will go into 22 one time. 1 times 14 is 14. Subtract and bring down. Okay, now I've got to divide 14 into 85. 14 will go into 85 6 times. Subtract. Now there's nothing else to bring down, so normally what I would do is I would take my remainder and put it over my divisor, and to get 16 and 1/14. Now, 16 and 1/14, 16 is the quotient, isn't it? And then you're adding your remainder over your divisor to it. This is actually what has always occurred. You've just never actually physically been writing that information down. So what you need to remember when you divide and you put your remainder over your divisor, we always write it like this: 16 and 1/14, just a real quick smudge together. But what it is your quotient, which is the result of the division. The result of the division is 16. The 1/14 is how much you have left over. So you put your remainder over your divisor, and it's actually an addition or a subtraction problem. So we're going to use that information to do long division with polynomials. Okay, so here is my division problem. This is what we have, okay? So this is my dividend, and this is my divisor, okay? Now, what I'm going to do is I'm going to take my divisor and I'm going to put it on the outside. And I'm going to divide it into my dividend, okay? So I've got 2x to the third plus 4x squared. Now, since I don't have an x, I'm going to put a 0 there as a placeholder, once again, minus 2. Okay, so what I have here is my dividend divided by my divisor, just like I did when I was working 225 divided by 14, okay? Now, in order to divide, this is what you're going to do. You'll take the first term of your dividend, which is 2x to the third, and you will divide it by the first term of your divisor, which is x squared. Remember, when you're dividing with the same base, you subtract your exponents. So 2 divided by 1 is 2. 3 minus 2 gives me x to the first. Since I have a 2x here, I'll put it right above the x term. Okay, so everybody see what I did there? And then I'm going to follow the steps of multiplication, or division, sorry. After I divide, I'll multiply. 2x times x squared is 2x to the third. 2x times 5x is 10x squared. 2x times 1 is 2x. So after you divide and multiply, your next step is to subtract. But remember, you're subtracting an entire polynomial, so make sure that you put parentheses around it. 2 minus 2 is 0x cubed. 4 minus 10 is negative 6x squared. 0 minus 2x is negative 2x. After you've subtracted, bring down your next term. Now, once again, take the first term, negative 6x squared, and divide it by the first term of your divisor. Negative 6x squared over x squared is simply negative 6. Since it's a constant term, make sure you put it above the constant term. And again, multiply away. Negative 6 times x squared is negative 6x squared. Negative 6 times 5x is negative 30x. Negative 6 times 1 is negative 6. After you've divided and then multiplied, remember to subtract to get your next set. Once again, because you're subtracting an entire polynomial, put your polynomial in parentheses. Negative 6 minus negative 6, 0. Negative 2 minus negative 30, positive 28x. Negative 2 minus negative 6, positive 4. Okay, so notice I have nothing else to bring down, and also when you get to the point to where the exponent of your remainder is smaller than the exponent of your divisor, then that means that you are finished dividing. So this exponent is smaller than this exponent, you are done, okay? So this 2x minus 6 is my quotient. That's what I got when I was dividing. 28x plus 4 is what I have left over. Remember, you put your remainder over your divisor. So my final result will be 2x minus 6 plus my remainder over my divisor. The quotient plus the remainder. And that is long division.